Welcome to this explainer. Okay, so if you've ever built an application powered by a large language model, you already know the pain of chaotic outputs. It's so frustrating, right? One minute, your AI agent, which is basically just a smart bot that uses tools to complete a task, is brilliantly answering a complex question. But then the next minute, it's completely stuck in this endless loop of calling the exact wrong tools over and over. You really want that AI magic, but you absolutely need the predictability and reliability of traditional software. Well, that is exactly where Langgraph comes in. It's essentially the ultimate framework for taking the steering wheel back and gaining total, absolute control over your AI workflows.
All right, let's take a quick look at our agenda for today. We'll start with number 1, welcoming you to Langgraph. Then number 2, we'll cover nodes, edges, and state. Number 3, building your first agent. Number 4, multi-agent workflows. Number 5, debugging and deployment. And finally, number 6, how Langgraph compares to the rest.
So let's dive right into section 1. Welcome to Langgraph, taking the steering wheel back. Now, we're moving way beyond simple, basic chat interfaces here. We are stepping into the world of complex, stateful, agentic workflows. So the crucial takeaway here is that Langgraph is a low-level orchestration framework. But what does that actually mean for you as a developer? Well, it means you can seamlessly mix highly predictable, hand-coded deterministic steps, like your standard if-then logic that runs the exact same way every single time, with flexible, LLM-driven AI steps. And you can do it all in a single graph. You no longer have to choose between AI flexibility and software reliability. You literally get to architect exactly where and how the AI applies its reasoning. To make this happen, Langgraph is built on 3 core principles. First up is controllability. Because it's low-level by design, you can enforce reliable, rock-solid outputs even when you're working with wildly unpredictable models. Second is human in the loop. Langgraph actually has a built-in persistence layer. This means you can pause a running workflow, have a human physically inspect or tweak the data, and then resume it perfectly from where it left off. It's a real game changer. And third, streaming first. Let's be honest, agent applications can sometimes take a really long time to run, so real-time streaming updates are baked right in to keep the user experience incredibly smooth. Ultimately, these 3 principles let you stop fighting your infrastructure so you can focus entirely on your actual business logic. Let's move on to section 2. Nodes, edges, and state, the conceptual foundation. Let's break down the atomic units of our graph theory using a highly relatable, everyday analogy. Think about making breakfast. In Langgraph, a node is simply a standard Python or JavaScript function. It's just a specific unit of work. So if making breakfast is our whole graph, a node is the physical action of, say, cracking the eggs or whisking them in a bowl. It takes some information in, does one specific job, and hands something back. Honestly, if you know how to write a basic function, you already know how to write a node. Okay, so what about an edge? Well, edges are essentially the decision makers of your application. They route the entire flow. An edge looks at what literally just happened in your node and decides where to go next. Going back to our breakfast analogy, an edge is what decides whether those eggs need a little more whisking, which routes you back in a loop, or if they're finally ready, moving you forward to pour them right into a hot pan. And tying this whole operation together is the state. You can think of the state as a shared data structure. It acts as the shared memory for your entire graph. If our graph is making breakfast, the state is essentially your kitchen counter and your recipe card. Every single node reads the current status of the ingredients from that counter, does its job, and puts the updated ingredients back. It reliably tracks your data from the very first node to the absolute last, ensuring your LLM never, ever loses context of the conversation or the task. All right, section 3. Building your first agent step by step. Let's bring all these abstract concepts to life. Once you've done a quick pip install Langgraph to get your environment ready, step 1 is defining your language model and the exact tools it's allowed to use. Maybe that's a basic calculator or a web search function. Step 2 is defining the state. Now, this is absolutely crucial because it determines the interface for every single node in your graph. By using something like messages state, you're making sure that every new message or tool output is safely appended to the ongoing chat history, rather than accidentally overwriting everything that just happened. Next up, we actually separate our logic out. Step 3 is defining the model node. Listen, this node's only job is to look at the state, call the LLM, and let the AI decide if it needs to talk to the user or if it needs to call a tool. Step 4 is defining the tool node. So if a tool was chosen by the AI, this node steps in, actually runs the code, like executing that web search, and returns the result. And this just brilliantly illustrates how Langgraph forces us to isolate the LLM's chaotic decision-making process from the actual physical execution of the tools. It keeps your code incredibly clean and super easy to debug. Finally, we hit step 5, adding our conditional edges. This is the routing logic that literally says, hey, if the LLM requested a tool, go over to the tool node, but if not, just go to the end. And then step 6 is compiling the state graph, which is essentially packaging the whole shebang up. Compiling weaves all your nodes and edges tightly together, locking them into a fault-tolerant workflow that is ready to guide your users seamlessly through their journey. But we have to ask a really critical question here. What happens when your application starts to grow? What if a single generalized agent just isn't enough to handle your highly specific, complex user journeys? Because if you just keep shoving dozens of tools and these massive paragraph-long instructions into a single prompt, your LLM's performance is going to degrade, and fast. It just gets confused. Which perfectly leads us to section 4, multi-agent workflows. Divide and conquer. So the ultimate solution to a confused, overloaded agent is to literally divide and conquer. We take complicated problems and we split them into tractable, bite-sized units of work, where each piece is handled by a specialized agent. Langgraph is absolutely perfect for this, and you can actually architect these multi-agent systems in a few different ways. You could have multi-agent collaboration, where your specialized agents share a single scratchpad of messages, meaning they see everything the others are doing. Or you can use an agent supervisor model. Here, a central router manages specialized agents that keep their own independent scratchpads, and they only return their final polished answers to the wider group. You can even build hierarchical teams, where subagents function as complete, independent teams working under one top-level supervisor. By grouping tools and using highly focused prompts for each specialized agent, like having one agent dedicated purely to web research and another dedicated strictly to writing, you are going to see significantly better, faster, and far more predictable results. Okay, moving to section 5, debugging and deployment, building your safety net. Let's be real, writing complex AI loops, especially when you have multiple agents interacting with each other, means you absolutely 100% need a safety net for common mistakes, like agents getting stuck in infinite loops, for example. Thankfully, Langgraph doesn't leave you hanging. It's part of a very robust ecosystem. By pairing Langgraph with Langsmith, you get just unparalleled observability. You can trace exactly which node executed, what the state looked like at that exact millisecond, and exactly where an error popped up. There's even a Langsmith engine that automatically detects issues within your traces and literally proposes fixes for you. A great best practice here, by the way, is setting a strict recursion limit so a confused agent just physically cannot run forever. And when you are finally ready to ship, the Langgraph platform provides this purpose-built infrastructure to deploy these long-running stateful agents as scalable APIs. It is a completely headache-free path right into production. Almost at the end, section 6, how Langgraph compares, choosing the right tool. So let's address the elephant in the room and compare Langgraph directly against a couple of other really popular open-source agent frameworks. First up, AutoGen. Now, AutoGen frames multi-agent interactions primarily as a conversation between entities. Langgraph, on the other hand, explicitly defines agents and their transition probabilities using a mathematical graph model. And that explicit graph structure just provides a much better developer experience if you are building really opinionated workflows that require precise, non-conversational routing. You dictate exactly how the flow works, rather than just crossing your fingers and hoping a conversational dynamic sorts everything out. And then, of course, there is Crew AI. Crew AI is fantastic if what you're looking for is high-level abstraction. It gives you these out-of-the-box, role-playing, multi-agent teams with very little setup required. But if you demand ultimate, low-level controllability, like if you need to deeply mix your own custom deterministic Python code with AI reasoning, Langgraph is completely unmatched. It doesn't hide the mechanics behind the scenes. It actually hands you the levers to pull. Wow, so we've gone all the way from the basic concepts of nodes and edges right through to deploying complex hierarchical agent teams. By using Langgraph as your foundation, you no longer have to just close your eyes and hope the LLM does what you want. You define the rules, you control the state, and you orchestrate the flow. So, with ultimate control over your LLM workflows now in your hands, what highly controlled multi-agent system are you going to build next? Thank you so much for joining this explainer, and happy building.